This is section 6.3, and we are finding solutions of polynomial equations. And we're not going to do a lot of factoring in this section. We're going to do it a little bit different, so really follow the directions on the homework so that you're doing it correctly to get credit for your homework. Instead of factoring, we're going to use GCF and graphs, finding the zeros, and possibly using the tables. The tables will only work when they are whole numbers. So if they're not whole numbers, we have to go to calculating zeros for this section. We're going to move into synthetic division in the next section. So this section, we're just going to work through some of these skills that I have here for you. So to find the zeros, finding zeros is the same as solving. So if it says solve the polynomial equations, I'm giving you factored form in these two. So can you convert factored form to actually solving or finding the zeros? And we did this in Algebra 2 where you set each factor equal to 0. (2x minus 1 equals 0 and x plus 5 equals 0. And if you can do this, so I want to see this work on your homework. And again, if you don't have work, you're not going to get credit for your homework. So be very sure that you are showing the work. This is where a lot of your points are coming from this trimester. So I do expect to see work on your work and completed homework. So this one here, if you can solve this two-step equation without showing this, but be very careful. Students make very silly mistakes when they don't show their work. So on this one, I'm solving for x, so 2x equals 1 divided by 2. These are just two-step problems, so x is 1/2. And then this one's a one-step problem, so x is -5. So be very careful. Common mistake is to say 5 or -1/2 on this one, which wouldn't be correct. So be really, really careful. So we solve this. This is the factored form, and here are the solutions to that. This one over here, we have 2x plus 3 equals 0 and 5 minus x equals 0. And these are both double roots, so we know that this is going to be a fourth power or quartic equation. And so we know there's 4 roots here, just like we know this is a quadratic equation. So we know there's going to be 3 roots, and they're all accounted for here. Being that these are squared, there's actually 2 of them. So these are both going to be double roots, and you want to note that on your quiz and your homework. So this one, solving this one, subtract 3, divide by 2, so that's going to be -3/2. And this one right here, this one's a little bit trickier, so be really careful on the positive and negatives. So I would just add x to both sides, and you'll have 5 left on that side and x on this side. So x is equal to 5. Another way to do it is move the 5 over, but then you have to divide by -1 on both sides. So be really careful that you end up with a +5 on that one. Okay, let's take a look at these ones. So on this first one here, I'm going to show you, I'm looking the graph on this one. I know there are 2 turns, and I know it's cubic. The turns is 1 less than the exponent, remember. So on this one right here, I'm going to do a GCF first, following the directions. So what do these 2 terms have in common? They have a 2 in common and 1x in common. And if you took a 2x out of the first one, I'm left with x squared minus, if I took a 2x out of this one, I'm just left with a 4. And one way to check this is just by saying 2x times x squared, is it x cubed? And 2x times -4, is it -x? So you can double check your work on that one. And then I have factored form, so now I'm going to find the zeros. So I end up with 2x equals 0 and x squared minus 4 equals 0. So if I solve this, I'm going to divide by 2. So x is going to equal 0, because 0 over 2 is 0. And this one here, I'm going to add 4. I could factor, it's the difference of squares, but I'm just going to go x squared minus or equals 4. If you square root both sides, x equals plus or minus 2. And notice I do have my it's cubic, so I have 3 solutions: 0, 2, and -2, and you can write it like that if you want to. So if I was going to just do a sketch of this one, notice I have not used my calculator. 2 and -2, and this is cubic, and it has 2 terms to it. So if you remember from a previous section here, it will look something like that. So I did no calculator. Okay, let's look at the next one here. Let's first of all look to see if they have any GCF. So there are 4 terms here. There are no GCFs. So now I'm finding the zeros. I can't even factor that. I could do factor by grouping, but we're not going to be doing all the factoring on this. So we're going to actually move ahead to look at the graph on this one. There's no GCF, so we're going to graph this, and we're going to calculate the zeros. And this one, we could do it that way, or we could look at our table. And I'm going to get this one on the calculator. I'm going to pause for a second and put this on the calculator to show you this one. Okay, so what I did, hopefully if you paused, or I would pause right now and get this in your calculator. So here's my equation right here. I changed my windows, being that there was a 20 in the problem. I went from -20 to 20 on both the min and maxes. And then when I graph it, it looks like this. So I'm noticing that there is a 0 here, here, and here. And if you look around it, they kind of hover. If I were to guess, it'd be 2, -2, 3, 4, and maybe -5-ish. So I'm going to look at my table here. One way you could do it, if these are all whole numbers, they'll be on my table. So here's my table, and I'm looking when the y is 0. So the y is 0 at 2. And I'm going to scroll this way to see if -2. So the y is 0 at -2 and 2. And then I need to see, I think there was another -1. So let's see if I can see the y in here. And there we go. The y is 0 at, -5. Everybody see it right there? So I'm looking for the y's are 0 and where they are 0 at. So if I go back, if it didn't work that way, I would have to use my, calculate my zeros. I'd have to calculate the 0, number 2, and I'd have to do the left bound, right bound for each of these if it wasn't a whole number. Okay, so now that I have that graph, I saw that the x was equal to -5 and plus or minus 2. And this is a cubed equation, so I'm looking for 3 solutions. So make sure they're all accounted for here. So I have -2, and I want to make sure I mark these. So I'm really being picky on this section as incompleteness of your homework, that you're showing where these zeros are, and then you're showing the graph. So this is a cube function. This is a positive a. So it is going to look like this, which we already saw. We didn't even need our calculator to show us what that looks like. So be careful that you have shown all the work that I'm showing on here for your homework, so that you get the total 5 points, so you don't lose points on your homework. You're not able to resubmit that after submitting it one time. So there's no resubmission, so make sure you do a really good job the first time through. Okay, let's take a look at this next one here. And this one here is a trinomial. There's no GCF. So we're going to look for the zeros on this one. Go ahead and pause the video for a second and put this in your calculator and get the graph on your calculator, and then take a look at your table just to see if you can see any of those zeros. Okay, so here's the graph of mine. I hope you did it on your calculator so that you're aware of how this works. This one's a little bit tricky. If I were to look at the table, this is why I don't like the table. I rarely ever use the table anywhere in this whole class, personally. If you look at the table here, where is the y 0? It's at -2, and that's the only one I'm seeing on here at -2. When -2, 0, and there should be another one around 0, 0, but I'm not seeing it, so it must be a decimal. So let's take a peek at our graph again, and let's find those zeros. So I'm going to calculate a 0, which is number 2, and I'll do that one first. I want to be left bound, enter. If you remember how to find zeros, right bound, enter. And there's my 0. This number here, -1 e to the -12, remember that rounds to 0. So -2, 0 is one of my zeros. Let's try to find the other one. It looks like it's at 0, 0, but I didn't see it on my table, so I want to calculate that 0. So I want to be left bound of that point right there, enter. And then right bound, enter. I don't want to guess. And notice that one's at -0.20. So I'm going to go back to here. I'm going to draw out my graph. And it goes through, and we know it's a parabola because it's an x squared opening up because it's a positive, even if we didn't have the graph. So I have a point right here that's going to be -0.20. And then I have this point here, which is -2, 0. So if I'm trying to solve, directions on here were to solve, I would have x equals -2 and -0.2 as my solution. And this is the work. So you cannot just have this as an answer and expect to get credit for this U of M class. You need to have your graph. You need to have the ordered pairs. You need to have these marked. I want to make sure you know that these are the zeros. You're not trying to find the vertex. You're trying to find the zeros. So this work is a complete work for this problem to get full credit. Okay, let's take a look at this next one here. So this, I know I'm looking for 4 roots or 4 solutions. And because of the 4th power, I know that there are 3 turning points, right? And if I did a GCF on here, which I could do, but we could just graph it also. I could take a GCF out. Let me just show you how that works. So I could take an x squared out of everything. I'd be left with an x squared minus 3x plus 2. And then I'd have x squared equals 0. So I have 0 as a double root. And so I'm looking for 2 more roots there. So I am just going to put this entire original problem into my calculator, and I'm going to show you that on my calculator. So pause the video right now and get that on your calculator, please. So this one, it's a little bit hard to see here. I left my parameters in that I had last time. So I'm going to go into my window. I'm just going to change it to -10, 10, as I see that it's hovering around 0. I'm going to do that for this one too, and regraph that. There it is. And notice that it does go through 0, 0, that one point that I was looking at. And it's still a little hard to see. It looks like it goes up and then it goes through 1 and 2 roughly. And if you look at your table here, it does go through 0, 1, and 2. So it does cover all those points using the table on this one. Or I could go calculate a 0. It's pretty fast to do this. And I am going to be to the left of where I think it's going to go through the x-axis. I'm going to go to the right of it. Make sure I'm down far enough so I can see that. And that verifies, yep, it goes through 1. And then I'm going to do that one more time and see to make sure that it goes through, whoops. Calculate a 0. I'm going to make sure it goes through that number 2. Also enter. Takes very little time to do that just to be sure. And it does go through 2 also. So it does go through both those points. So if we're going to go back to our notes and it's going to go through 0, 1, and 2. And then we are going to make the graph. And we know, even if we didn't see the calculator, that this is to the 4th power. It's a positive a in front of there. So we know it's going to look like a W, but we know it because we were on the calculator too. And then we're going to put a 1 here and a 2 here. And here is my final answer. And again, I really want to make it clear that on the quiz, you need to show all this work to get full points on the quiz. Okay, looking at this one, use a graph of f of x to solve f of x equals 0 and find the factorization. So here I'm giving you the zeros. There's 4 of them. So x equals -5, 2, 4, and 7. So I'm trying to find f of x. So if the solution was x minus 5, the factor it came from must have been x plus 5. If the solution was 2, the factor it came from must have been x minus 2. Just so you remember how we did that. To find the solution, we subtracted 5 from both sides. So x equals -5. And that comes right up there. And then this would be x minus 4 and x minus 7. So your final answer would be f of x equals 0 and find the factorization, which we did right there. Next one, we're doing the exact same thing. So we've got a -4, -1, and a 6. So x equals -4, -1, and a 6. So my f of x equals x plus 4. That's the factor that came from. X plus 1 and x minus 6. And that is my final answer on that one. If you want to pause right now and do some of your homework, you can, but I'm going to go on to the second part of this video. So it'll probably be about 30 minutes long. I'm thinking like the other one. I have 2 problems left. And I believe these come out of your homework, 37 and 48. So 37 says the future value of $2,000 invested for 3 years at rate R compounded annually is given by this equation right here. Graph this function. So this would be the X window and this would be the Y window. So you're going to graph that function. And I'm going to grab my calculator. So go ahead and try to get that on yours and pause this. Okay, so here's my graphing calculator. And, oops, not sure what happened here. So here's my graphing calculator. What I did in Y1 is I put the 2,000 and the 1 plus 3, or 1 plus x cubed, and then I changed my windows to match what it said on my problem. And then here's what my graph looks like. And the second question asks us, which I will graph in just a second here, find the rate R as a percent for which the future value is 2.662. And I think that's supposed to be a comma actually, 2,662. So what you're going to do with that is you're going to take this 2,662 and you're putting it in for S. So that's going to actually end up to be your Y2. It's a horizontal line. And so I'm going to go back to my calculator, go into my Y equals, and I put that in. Actually, I put that in wrong. So I'm going to change that, and I'm going to get the graph going on here. So I'm going to pause this while you do yours. So that is what my line looks like. So this is my Y1, my blue line, and my Y2 is my red line. And so I ended up putting that here. So this would be work that would be have to be there for credit on the quiz for this section. And then it says we need to find the intersection, right? We need to find that. So I'm going to go back here and I'm going to calculate the intersection number 5. I'm going to just push enter because it hops by itself. So the intersection is 0.1 and 2,662. And so I'm going to put that on my screen here too. So this is going to be 0.1 and then 2662. So the answer to this second question here is 0.1 or 10%. So if the rate was 10%, the future value in 3 years would be that amount. Okay, we're done with the second part. The third part, find the rate R as a percent for which the future value is 10,368. So I'm going to go back to my calculator. I'm going to go back to my y equal, and I'm going to clear this out, and I'm going to put in my 10,368. And I just want to show you what's going to happen here. So when I graph this, I'm not going to see my horizontal line because it's above 5,000. So it's going to be somewhere way up here. So I'm going to go back into my window, and instead of my top as 5,000, I need to change that. Oops. And I might make that 15,000. And let's see if that helps us see the graph. Nope, so I'm going to have to increase my X window. So I'm going to just pause this while you try to figure out your window and get a nice window for yourself. I actually go into your Y equal because I changed that to 3456. I matched it to number 37. I added a different number when I was teaching this the first time through. So let's just make that 3456. Let's not change our window. And then here's our graph. And then I'm going to calculate the intersection again. Oops. And that ends up to be 2%, or 20%, sorry. So we go back to here. So I changed this to match your book, just so you can use this for your homework then. And that's going to be 0.2 or 20% in order to get this amount after that many years. Okay, so that is 37. And let's take a look at the last problem for this section, which is number 48. So 48 is the percent of the U.S. population that was foreign-born during the years 1900 to 2010 is given by this function. So you're going to enter this into your calculator, where X is the number of years after 1900, so that's where X is 0. Use graphical methods to determine the year after 1900 when 16% of the population would be foreign-born. So this is going to be, this here is going to, because this represents, this Y represents the percentage of U.S. population that was foreign-born. So that's going to go into there just as that because it's in percent. So it is 16%. So that's going to be, that is going to go into your Y2. So go ahead and pause this right now and get that in your calculator. So I put mine in my calculator. Here's my Y1, that full equation. Make sure that you put it in there correctly. I even made an error on that one, so be sure it won't come out right if it's not perfect. And then here's my 16%. And then I adjusted my window and I graphed it. Here's what my graph looks like. So I want to know this point right here. So I'm going to calculate the intersection. And I'm going to get 114.866. So when I go back over here, I'm going to make that graph. And then here's my line right there. So this is part of your quiz, if this is on your quiz. And that was 114.87, 16. So what year was that? I would take 1900 and I'd add 114 years to that, and I would get 2014. It's towards the end of 2014. This is not 2015. I know the book says that, but we never round up to another year. We stay in the same year that we're the same year. Okay, that was probably the most common mistake on the last quiz, was students rounded up on one of the problems on that. So that's that problem. So that's the end of that problem. Noticing my work here. Notice my work here. That is showing me that you knew how to do this problem. And here is your assignment for 6-3. The time frame will be the same this week as it was last week. I know we have no class on Friday. Actually, no school on Friday of this week. So check the calendar for the schedule for this section.